Next, we talk about phenol. All right, remember phenol? Good friend, right? Phenol. This is phenol. All right, this is phenol. All right, and then what happened is it will go through the equilibrium expression also. All right, the dissociation. This has a term. It's called phenol phenoxide ion. You need to know all these terms because you need to explain, right? So what happened in phenol is a stronger acid, remember, than water and alcohol. Why so? This is the explanation. Because the p orbital of the oxygen atom will be able to overlap with the pi orbital of the carbon atoms in the ring. We did this before in the previous topic, which I'll show you again. Such that the negative charge is able to spread around the ring or into the ring, and this increases the stability of the phenoxide ion by resonance structure or resonance effect. And therefore, it is less likely to accept a proton. Because it's stable, you don't need to take back H+. Therefore, phenols are stronger acids than alcohol. Let me draw it out and you sure get it. Dun, dun, dun. Again, I don't have all these words. I only have this diagram in mind. Remember, we are always looking at the phenoxide ion. Okay? It has a lot of lone pair because it's negative charge, right? We just need one of them, right? In fact, it has 3 pairs. Everyone okay? Cannot? But we just need one pair to discuss. Don't forget, this is a benzene ring. So what happened? Here we go. There is unhybridized 2p orbitals, dumbbell shape. The pi bond, there are 3 of them. Therefore, it uses the unhybridized p orbital. Remember all this? Dumbbell shape also. And the electron, which is who? Which is this lone pair, can you see? Can delocalize from carbon to carbon. Everyone okay? And therefore, we say this is what we call a resonance structure, which is very, very stable. And therefore, less likely to accept back the H+. All right, I write a bit more so you can see. Therefore, is more acidic. Okay? Then the alcohol and water. That's it, which is what I discussed here. Oh, when I say negative charge, it also represents the lone pair. Okay, in a way. If you cancel, you put them together. Say, lone pair able to delocalize into the ring, and therefore the negative charge is able to spread the ring. Is it okay? Negative charge. Why there's negative charge? Because of the extra electron. Remember that? Electrons are negative. Everyone okay? So in MCQ, be very careful. Sometimes they use negative charge. Sometimes they say the lone pair can delocalize it. It means the same thing. Can everyone be a bit flexible? Understand your concept, and therefore the keywords. Okay? Can I? All right. So the negative is due to lone pair once again. When your lone pair go in, means this negative not so negative anymore. Okay? Make sense? Yeah. So here we go. Let's talk about the effect of ring substituent on the phenol, which is the same thing. So we're going to fly through this. Very easy. This part is still very fun. Okay. Nothing to memorize. So here we go. We have been doing this really one at a time. Electron withdrawing group like this, in data booklet. What will happen? Now, don't forget, what we need to do is this. Don't look at the H, all right? Instead, look at it in terms of its conjugate base. So which is my control? In a way, I say this is my control, all right? And then when you have more electron withdrawing group, let's take a look, right? So this one has 1, we withdraw electron density. This has 3, draw over here. Take a look at the lone pair. I hope you agree with me. If this is this big, this is in the middle, this is tiny. Okay? And therefore, I'm very sure that this one is tiny means the one to take back H+, so it is a very good acid. So this should be the strongest acid among the 3. This is the weakest acid among the 3. All right. And therefore, we look at the pK value. This is the smallest, or rather the biggest. Therefore, Ka is the smallest. Opposite is true. Everything is true. All right. The opposite is always true. Let's take a look on the other side. Electron donating groups. Okay, ready? Presence of electron donating group, which is those few that is on data booklet. So again, what are we looking at? We are looking at this. Ta-da, ta-da, ta-da. Very easy. All right. So take a control first. Who's the control? I believe this is my control. All right. This is my control. Now, presence of electron donating group. Here we go. Electron donating group. So donate, this donate, right? According to the top part, and this therefore the data booklet. Now both donate, right? Both donate. So it will reduce the delocalization of negative charge on the anion on the oxygen atom into the ring, and it destabilizes it, cause now your lone pair very big. Make sense? All right, very negatively charged. So it reduces ionization. So I expect both of them should be weaker acid than the control called phenol, i.e. the pK value is bigger. Everyone okay?
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.